Okay, ji, welcome back. Let's wait for 1-2 minutes so that the people they can join. Okay, ji, so as this is basically a common emitter configuration circuit, so the output characteristic curve they will be in between the output current and that of the output voltage. The output current in case of common emitter configuration circuit is IC and the output voltage is VCE. So the characteristic curve is between IC versus VCE, right? Now for the base current, because IC is dependent upon IB, as we know from the equation, IC is equal to beta times IB, as we have just written it over here. IC is equal to beta times IB, right? So depending upon that, the value of IB is very important, and we know this thing that for different values of IB, we have respective curves of IC which were plotted previously as well. So जी आवाज आ रही है जी?
Yes, sir.
Yes, sir.
Okay जी, kindly
Yes.
आवाज ठीक है, पर सर ये जो आपकी स्क्रीनें बार बार घुस जाती है।
जी स्क्रीन नहीं नजर आ रही?
ठीक चल रहा है।
अच्छा जी,
आ रही
ओके।
है सर, बिल्कुल ठीक
कर रही है सर।
सर नजर आ रही है पर बीच में रुक जाती है, फिर एकदम सामने सारा नजर आता है, फिर रुक जाती है, इस तरह से होता है।
ये आपका नेट कमजोर है।
हो सकता है आप लोगों की साइड पे कोई नेट का प्रॉब्लम हो या मेरी साइड पे प्रॉब्लम हो, क्योंकि चल रहा है नेट का।
नहीं सबको आती है सर।
अच्छा
सर, ये जनरल डिले होता है, ये ऐसा होता है इसमें।
ओके जी, ओके। सो for different values of IB, we have respective curves for IC, and from our previous knowledge, we have seen that we have the curves, they are something like this for different values of IBs, right? Now, what we see that when, and also we have curve over here when IB is equal to 0 over here, right? When IB is equal to 0, we have curve which is just close to that of the horizontal axis, and we will have okay, when IB is equal to 0, the curve is just close to the horizontal axis. Now from the equation, if you see, we have the equation over here. We have the equation for the output side, which we have just shown it over here, that VCC is equal to ICRC plus VCE, or VCE is equal to VCC minus ICRC. C, right? Now we also know this thing that IC is equal to beta times IB as well. Now this means that when IB and IC, they are interrelated with beta. Now if we say that IC is equal to 0 over here, right? In this equation, if we say IC is equal to 0, so this means the current flowing in the collector circuit is 0. So what will be the situation, right? This means if we put IC is equal to 0, IC is equal to 0, so this means VCE is equal to VCC. Are you with me?
Yes, sir.
Right? So in the equation, if we put
Yes,
I
sir.
equal to 0, we will get VCE is equal to VCC, right? And when IC is equal to 0, where we are basically in this, in the characteristic curve, if you see, when IC is equal to 0, we are something over here. We say this is the point where we have the value VCE is equal to, we have the value which is equal to VCE is equal to VCC over here, right?
Yes.
When IC is equal to 0 in the equation. Similarly, in the equation, if I put VCE is equal to 0, right? If I put VCE is equal to 0 in the same equation, what we are going to get? If I say
This is equal to
VCE, if I
ICR is equal to VCC.
VCE is equal to 0 in the equation, if I put this thing, right? So if I put VCE is equal to 0 in the equation, I will get VCC is equal to ICRC. Are you with me?
Yes, sir.
Or I can say, IC is equal to VCC divided by RC, right?
yes.
So this means on the curve, the characteristic curve, I'm going to get another point over here. So I'm going to get this point over here, which is now IC is equal to VCC divided by RC. Right? Now, if I see this thing that I have got one point at the horizontal axis, one point at the vertical axis, right? Now, depending upon the value of IB, kindly listen to me carefully, right? Now, depending upon the value of IB in the circuit, and if I say IB, or here is IBQ, this is the value. And how I'm getting this value? I'm getting this value from the input side. From the input side, this is the equation which we obtain. IB is equal to VCC minus VBE divided by RB. So if I say this is the value of IB, which I say this is now the value IBQ over here. Are you with me?
Yes, sir.
Yes, sir.
If I
No,
say
sir.
this,
No,
this
sir.
is this is the value from the equation which I am getting, and I say let's suppose this value IB which we are getting from this equation is VCC minus VBE divided by RB. Depending upon these values, we are getting a value IB, and I say this value as IBQ. Now this IBQ value is providing me on the curve. I say this is IBQ over here, right? And if I join the 2 points on the horizontal axis as well as the vertical axis. On the horizontal axis, I have the point VCC when IC was 0, and on the vertical axis, I have a value when VCE was equal to 0, I have a value VCC divided by RC. So if I join these 2 points, what I am going to get? I am going to get a straight line. Are you with me?
पॉइंट की समझ नहीं आई सर.
Yes, sir.
No, sir. Sir, explain करे, please.
Okay, therefore I said listen to me clearly, right? So what we have done, we have taken 2 points from the equation which was the output circuit equation. We have this equation VCC or VCE is equal to VCC minus ICRC, and what we have done, we have taken 2 points. Once we said IC is equal to 0, VCE is equal to VCC, and then we said if VCE is equal to 0, we get IC is equal to VCC divided by RC, 2 points, right? And these 2 points, we have mentioned it in our characteristic curve. And what we have shown it on our characteristic curve, 2 points. One is when IC is equal to 0, we get VCE is equal to VCC. And similarly, when VCE is equal to 0, we have another point VCC divided by RC. Now, if we join these 2 points, so we are going to get a line over here, right? And this line which we have just drawn it on the characteristic curve. Are you with me?
Yes, sir.
Yes.
Clear.
Yes, sir. Yes,
ठीक
sir.
है जी?
Clear, sir.
Now, depending upon the value of the base current from the equation which we have said, that this value is now IBQ, right? So this IBQ is being mentioned over here with this line over here, right? This is the line. Now, where this line cuts the straight line over here, this point over here is being called as the Q point, where Q point is called the point of operation of this transistor. Are you with me?
Yes.
Right? So where this straight line cuts the line of the base current, which is providing the collector current over here, wherever this cuts this straight line, this point is called the point of operation. or which is called the quiescent point, or it is the point where the transistor will be operating for specific values of different components, which is VCC, RC, RB, and the value of beta, which is going to be there. Are you with me?
Yes.
सर एक सवाल है सर
जी जी पूछें।
सर इस लाइन ने तो इस कर्व को कई दूसरी जगह भी कट किया है ना, उनको हम क्यों स्टार्टिंग पॉइंट मतलब ऑपरेशनल पॉइंट क्यों नहीं कहते?
यही तो मैं आपको बात बता रहा हूँ। If you see,
जी
we have the input side of the equation, which is this IB is equal to VCC minus VBE divided by RB, right? And we say, let's suppose this value with the values of VCC, VBE, and RB, we are getting a value IBQ over here, right? Now, due to this value, we are getting the corresponding value of the collector current, which is IC is equal to beta times IB, right? Now, this means if we go to the characteristic curve over here, we have the corresponding value of IB, which is providing the corresponding value of IC. And whenever this straight line cuts, the specific value of IBQ, which is providing the IC over here, that point where this line, the straight line cuts the characteristic curve, that point is called the point of operation of the transistor. Are you with me now?
यस सर, क्लियर सर।
ठीक है जी, because as you can see there are different characteristic curves, right? For different values of IB there will be different value of IC, right? But depending upon where the IC is actually taking place, because these characteristic curves, they are there for different values of IB and ICs, right? So now the circuit is providing us the specific value of IC or specific value of IB. So depending upon that, we will be getting the point of intersection of the straight line to that of the characteristic curve. So whenever the point is being cut of the characteristic curve, we get the point of operation, which is the quiescent point or point of operation or Q point, right? Now, if we correspondingly just make a dotted line over here. So this point over here is called VCEQ, and the corresponding point over here is called ICQ over here, right? So this means this is the Q point for the current and the Q point for the voltage over here. Are you with me?
Yes, sir.
And similarly, if I say I change the value of the input side, previously I said it was, let's suppose, IBQ. Now due to the variation in, let's suppose, VCC, right? Due to the change in the biasing potential, what we can do, we can actually have a change in IB, or due to the change in the RB resistor over here, right? So change due to any of these two, VCC or RB, we can have a variation in IB. Are you with me? If these components, they changes, if the component VCC or RB changes, we will have a change in the base current,
Yes, sir.
right? So if we are going to have a change in the base current, this means correspondingly, if you see this equation over here, we have the corresponding change in the collector current as well. So if the base current varies, the collector current will also vary, right? So this means if the base current varies, the collector current will also vary. And when it will vary, so this means either it can go over here. Let's suppose it will become IB2, or it can go over here as IB1, right? So if that will happen, this means the Q point can either move over here as Q2, or the Q point can either move over here as Q1 over here. Are you with me?
Yes, sir.
बात समझ में आ रही है?
Yes, sir.
Yes, sir. आ रही है, sir.
So this means the point of operation can either move towards the saturation region, because if you remember, this region is, or here is called the saturation region, and this region over here is called the at the bottom is called the cutoff region. Do you remember
Yes.
that?
Yes, sir.
So by varying IB, we can either move towards the cutoff region, or we can either move towards the saturation region, right? So if the variation is so much that the Q point can either go into the saturation region, or the Q point can either go into the cutoff region. Because if the variation is, let's suppose we can either go towards IB, which is very close to the cutoff region, or IB can go and towards the saturation region. So this means the normal operation of the transistor might be affected, because what we need to do, we need to have the normal operation of the transistor in the linear region, right? If you remember that the normal operation of the transistor need to be in the linear region, right? And the linear region of the operation is that the base emitter junction need to be forward biased, and the collector base junction need to be reverse biased. Are you with me?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
ठीक है जी. So this means if the transistor goes into the saturation region, we do not have the normal operation of the transistor, and if the transistor goes into the cutoff region, again we do not have the normal operation of the transistor. So what we need to do, we need to have the transistor to be within its linear region, so that it should have the normal operation of the transistor, right? Now similarly, if you see this line over here, which is being taken from this equation, which we have said VCE is equal to VCC minus ICRC. Now we can also write this as, if you see, this can also be written as it can also be written as IC is equal to IC is equal to, from the equation, what we are going to get, IC is equal to VCC divided by RC minus VCE divided by RC. Are you with me?
Yes, sir.
Right? And what is the equation of the straight line? What is the equation of the straight line? Anybody?
लीनियर होगा पर उसका नहीं पता मुझे।
Straight line की equation क्या है? Do you remember that?
Y is equal to X.
The straight line equation is y is equal to mx plus c. Right? ठीक है जी?
Yes, sir. Clear.
Yes, sir.
Y is identifying the y-axis, x is identifying the x-axis, m is the slope, and c is the constant over here. Right? From your mathematics knowledge, you have this thing. ठीक है जी? So if you compare these two equations, so
तो भाई कामात सर मर्दाना
okay ji. So if you compare the two equations, we can see that IC is equal to the VCE is basically representing the horizontal axis, and the slope of the line is minus 1 over RC, and the constant is VCC divided by RC is the constant over here, right? So therefore, this line which we have drawn it over here is basically a straight line which is corresponding the two ends, which is one
सर
is
स्क्रीन नजर नहीं आ रहा सर
J. स्क्रीन नजर
सर
नहीं आ
स्क्रीन
रही?
नजर नहीं आ रहा ये
सर आ रही है सर नेट प्रॉब्लम
अब
सर
आ
जो
रही है?
स्क्रीन मेरे रिंग नो सर
सर स्क्रीन नजर आ रहा है लेकिन लिखा ही नहीं दिख रही।
सर वो स्क्रीन मेरे रिंग टूल आया हुआ है का पेज उस पे आया हुआ है सर
अब आ रहा है नजर?
यस सर आ रहे
नो सर सर
नो
सर
सर
स्क्रीन तो नजर आ रहा है लेकिन सर उस पे
आ रहा
वो
है सर
मिररिंग टूल का पेज आया हुआ है सर
अभी
सर
भी
नहीं
हमारे
सर
से
आगे आ रहे
ठीक है
आ
जी?
रहे सर आ रहे
नेटवर्क मसला
हसीब
है
आपके
हमारे
नेटवर्क में
सर
प्रॉब्लम है आ रहा है सर सर की स्क्रीन आ रही है हसीब आपके नेटवर्क में प्रॉब्लम होगा
मेरा नेटवर्क ठीक है, अब आपके साइड का प्रॉब्लम है ये।
यस सर
अभी
आपका
तक वो दो
नेटवर्क
इक्वेशन
ये सर आपका सब नेटवर्क ठीक है
रजनी हमाद सर ने कूदे
आपके साइड भी प्रॉब्लम हो सकती है, जरूरी नहीं कि हर वक्त मेरी साइड भी प्रॉब्लम हो। ठीक है जी?
ये सर
So if it is a problem on my side, so everybody will have the problem. If it is the problem on your side, this means this is the problem only on your side. ठीक है जी? So and now what we have the straight line equation, and we just compare it, and therefore we have drawn the straight line on this the output characteristic curve, right? Now there is another thing, that the RC value can also vary, right? If the value of RC varies over here, what will happen to this line over here? Now normally this line over here is being called as, this line over here is called as DC load line, right? Because on this, the Q point can actually vary from the saturation region, it can go into the linear region, and from the linear region, it can go into the cutoff region, right? So this line, this means on this, the Q point is going to vary from the saturation region into the linear region, and from the linear region, it can go into the cutoff region. So as you can see, I have mentioned three Q points. One is Q, Q1, and Q2. So either it can go above Q2 or it can go beyond Q1. So if it goes beyond, this means towards the downside. If it goes beyond Q1, so this means it will go into the cutoff region, and if it goes above Q2, it will go into the saturation region. Now if I say the value of RC varies, this means if the value of RC varies, what will happen to this DC load line? Now the point is that if the value of RC increases, right? If the value of RC increases in the circuit, this means the load line, or here, what will be the point over here if the value of RC increases? Anybody? Whether the point in the y-axis, which is the IC, where this point goes, if the value of
Downward side.
Upside, up.
Saturation की तरफ sir.
if the value of RC increases,
Downward, नीचे की तरफ side.
Downward आएगा सर, नीचे आएगा.
Downward आएगा।
ऊपर जाएगा, ऊपर
it will go over here.
ऊपर जाएगा.
If value of RC increases, the point will go down. If the value of RC decreases, this point will go up. Are you with me?
Yes sir.
Right? So if the value of RC increases, this means this point, we will have a line, something like this over here. Right? Are you with me?
Yes sir.
Yes sir.
If the value of RC increases, this means we will have a point like this, and the DC load line will have a slope which is less than the existing line. Now, if the value of RC decreases, we will have this point over here, right? And this point over here, this means the load line will be now this one, right? So this means with the variation in RC, the load line slope will also vary. Are you with me? And
Yes
when,
sir.
are you with me? No? Yes?
Yes sir.
Yes, sir.
Yes sir.
Right?
Yes, sir.
So when it will vary, so this means the Q point will vary over here as well as over here. Right? The Q point will change from here, or it will change over here. Right? With the variation in RC over here. Right? And if I say there is a variation in VCC, what will happen? If there is a variation in VCC,
इसके converse होगा.
so if I just take out this thing and I take out this thing, right? So if there is a variation in VCC, so if VCC increases,
Point will be upward.
Just there.
if VCC increases, what will happen?
Point will be upward, sir.
Upwards.
So this means if VCC increases, so we will have a point over here as well as we will have a point over here, right? Are you with me?
Yes, sir.
So this means the line will be something like this. If VCC decreases, so this means we will have a point over here as well as we will have a point over here, right? And we will have a line over here like this. Are you with me?
Yes, sir.
Yes, sir.
ठीक है जी? So depending upon the variation in VCC, we have the change in the positioning of the line. Depending upon the variation in the RC resistance, we have the variation in the slope of the line, right? ठीक है जी?
सेशन खत्म होने वाला है सर।
Okay. So is this point clear?
सर दोबारा
सर
बताइए
लास्ट
सर
लास्ट
Yes, sir.
सेंटेंस फिर से रिपीट करें।
Okay, if there is a variation in VCC, the positioning of the DC load line will vary. If there is a variation in RC, the slope of the line is going to vary, right?
यस
हाशिए पर अटक बोलेगा।
ठीक है जी?
सर ये लोड लाइन जरा एक्सप्लेन करें सर, इसके समझ नहीं आती। ये लोड लाइन क्या होता है?
लोड लाइन जो हमने पहले आपको बताया कि लोड लाइन is basically the line which we have represented it or here with the straight line equation that y is equal to mx plus c, right? Okay, we have less than a minute now, so probably it will the session will end. But y is equal to mx plus c, which can be represented and correlated with the equation IC is equal to minus VCE divided by RC plus VCC divided by RC. VCC by RC is basically represented as C, and minus 1 over RC is being represented as M, where M is the slope of the line, and VCE and IC, they are represented as the X and Y in the equation. And therefore, we have just shown that when we put IC is equal to 0, we get 1 point of the line. When we put E is equal to 0,